Welcome to this explainer brought to you by Forge College. If you're following our Ethereum Dev Stacks and Frameworks track, specifically the Hardhat Fundamentals module, you know we just laid down some serious groundwork in the C-level environment setup and tooling lesson. Today, we're getting started with Hardhat. We're going to unpack that foundation and meticulously inspect the blueprints of your newly initialized project. Think of it like taking delivery of this massive, highly complex machine. Before you even think about turning the key, you've got to know exactly where the engine is, how the wiring connects, and, well, why you suddenly have 3 extra screws left over. Okay, let's quickly review today's schematics. We're going to map out the Hardhat blueprint, tune up the configuration engine, decode your project dependencies, wire up some custom scripts, and finally prep for our next stop, TypeScript. Section 1. The Hardhat blueprint, mapping your newly generated workspace. Let's tackle that mild, totally normal panic every developer feels when a command line tool suddenly spawns a dozen unknown folders in their perfectly pristine directory. So what do all these auto-generated files actually do? When you run that initial setup, the tool hands you a working skeleton. But here's the thing. Understanding the spatial layout of these files isn't just neat trivia. It's absolutely crucial knowledge that saves you from massive misconfiguration headaches later. Because if you don't know where things naturally live in the Hardhat ecosystem, you'll be flying completely blind when it's time to upgrade your tooling. Or, worse, you'll be trying to troubleshoot a failing build at 2 in the morning, which nobody wants. Let's break it down. Think of your hardhat.config.js file as the main operating manual. Then there's package.json. That's your exact parts list. Your scripts folder is basically your control panel, where all your executable tasks live. Then you've got the contracts folder, which holds your raw materials, so your actual smart contract source code. And finally, the artifacts folder. That's the output tray where your freshly compiled smart contracts end up, totally ready to be deployed. Moving right along to Section 2, the configuration engine, tuning the core of your project. Let's zoom in on the literal engine of your workspace, the exact place where your compilation rules and network behaviors are firmly declared. We are talking about hardhat.config.js. You can think of this file as the bossy manager of your project. It dictates the exact Solidity compiler version you're going to use, it loads up all your essential plugins, and it carefully maps out your network connections. As a core part of the fundamentals we teach here at Forge College, we constantly emphasize that this specific file is the absolute source of truth for your project's behavior. Seriously, when things go wrong, you check here first. The crucial point here is making sure your fuel perfectly matches your engine. If your smart contracts are written using a specific version, say Pragma Solidity 0.8.17, your config file has to explicitly target that exact same version. If those two numbers don't match, your compilation is going to fail with some incredibly confusing version mismatch errors. It's a tiny detail, but aligning them turns a broken build step into a perfectly predictable, smooth one. Now, keep in mind there is a strict functional divide between your two most important project files. Your package.json handles the broader picture. It coordinates your general node tooling, your environment, and your dependencies. On the flip side, hardhat.config.js strictly dictates the mechanical behavior of Hardhat itself, so it manages internal compiler settings, optimizer runs, and plugin integrations. Keep their responsibilities neatly separated in your head, and I promise you'll save yourself hours of debugging. All right, Section 3, Decoding Project Dependencies, Understanding the Parts List. Now that our engine is properly tuned, we need to make sure we actually have all the right development tools installed and ready to go. Take a close look at the dev dependencies block in your package manifest. These are the tools you need strictly to build the machine. Think of them as your scaffolding, your wrenches, your testing gauges. They're absolutely crucial for local development and compilation, but they won't actually be shipped in the final product out to the blockchain. You'll typically see essential packages listed here, like the Hardhat Core package, the Hardhat Toolbox from Nomic Foundation, testing frameworks like Chai and Mocha, and ethers for contract interaction. But here's the vital catch. If a required plugin is missing from this specific list, Node will throw a module resolution error the very second Hardhat tries to run. That'll bring your entire workflow to a screeching, super frustrating halt. Moving on to Section 4, Wiring Custom Scripts, Creating Your Control Panel. Let's look at how we wire up our control panel in the package manifest so you can safely and predictably fire up this engine without having to type out massive, complex commands every single time. Setting up a custom script is a literal mechanical sequence. It ensures your project behaves identically whether you run it on your machine today or a colleague's machine tomorrow. Step 1, open your package.json. Step 2, locate the scripts object. And step 3, map out a custom command. Notice that we highly recommend using the explicit -network hardhat flag when you do this. By adding this precise command to your scripts block, you are essentially wiring a dedicated, perfectly safe start button. That -network hardhat flag, it guarantees you are strictly running on your local in-process network. It completely avoids those terrifying, heart-stopping moments where you accidentally deploy a test token to a live mainnet and drain your real wallet because you only meant to experiment locally. We've all been there. Let's try to avoid it. And then you get to the moment of truth, when you execute your brand new script and you see this exact log output returning in your terminal. It is the ultimate proof. It validates that your compiler, your plugins, and your dependencies are all perfectly aligned and talking to each other. Finally, Section 5, next stop, TypeScript, preparing for the next upgrade. We've successfully mapped, tuned, and tested our base project configuration, and this perfectly sets up our final architectural review before we initiate our next major system upgrade. Let's lock in the core mechanics we've covered today. Number 1, config files are declarative. They dictate exactly how the tools should behave. Number 2, your package.json is the absolute authority for what is actually installed in your environment. And number 3, relying on small, immediate script tests is hands down the best way to isolate errors fast. Before you start swapping out parts for the upcoming TypeScript integration, remember to keep your edits small and test them instantly to avoid getting trapped in endless debugging sessions. So here's the big question to leave you with. Are your project blueprints fully validated and ready for the TypeScript upgrade? Will your smart contracts survive the chaotic frontier of Web3? Or will a simple misconfiguration bring your entire dApp crashing down? Find out in our upcoming TypeScript integration lesson. Thanks so much for joining this explainer. Make sure to visit forge.college to explore more of our Ethereum DevStacks curriculum and other awesome Web3 learning resources. Catch you in the next one.